Hello, this is Mr. Henry, and welcome to lesson 2.5. This lesson is on applying the distributive property. It's a new property we're going to learn about. It's not as trivial as some of the other properties like the multiply by 1 or the associative property, which associative property is not trivial, but this distributive property will be used on almost a daily basis later on in the school year. This property is used a lot, all the time in Algebra 1. So this is something you really want to make sure for yourself that you're understanding as you're going through the lesson. Okay? So, evaluate the following. So our 4 get the goofs here, they just want us to do a little bit of math. So let's see what we got here. I'm going to, oh, that's not the right thing. There we go. I'm just making a little bit of space. They feel a little cramped to me. There we go. Okay, so number 1, we're taking a -4 times a -3. -4 times -3. So 4 times 3 is 12. So the number part's correct. The signs are the same, so the answer should be a positive 12. That's the rules for multiplication. Signs the same, positive. Signs are different, negative. Number 2, we have a subtraction. So I'm going to use KFC, so 8 plus a -15. The signs are different, so we need to subtract. And 15 minus 8, is it 7? Yeah. So the number part's correct. And then you keep the sign the bigger number, and that's correct. So I think that one's actually correct. 15 minus 8, 7. Yeah, it works. Okay, number 3. Let's see. The signs are different. And it's a plus sign, so we're going to subtract. Subtract. And then keep the sign of the bigger number. And number 4, we have to multiply that out, and I do not know that off the top of my head. I could do it, but I don't want to. So I'll write it out. 3.6 times 5. You do not line up the decimals when you multiply. 6 times 5 is 30. Carry the 3. 15, 16, 17, 18. And then there's one number after the decimal in the problem, so one number after the decimal in the answer. Get the number 18.0. And the signs are different, so the answer is a -18. All right. We have ourselves a bunch of vocabulary. So we'll start at the top. Equivalent expressions. Equivalent expressions are two expressions that have the same value. So an example would be like 3 plus 5. That has a value of 8. 4 times 2. That has a value of 8. Those two things would be considered equivalent expressions. Distributive property, the term of the day. The distributive property can be used to find the product of a number and a sum or difference. Basically what that means is if you have something times by a sum, an addition, or a subtraction, you can use this distributive property to find out what this multiplication actually gives you. The main reason why we're learning this, or the main reason we're going to use the distributive property, is going to be to get rid of parentheses in our equations later on. Okay, moving along. Term. Term are the parts of an expression that are added together. The parts of an expression that are added together. So if I had an expression 3m plus 5 minus 2k minus 9, this actually has 4 terms. There's this, there's this, there's this, and there's this. And you might be going, hey, dude, this is not being added together. But it is if you do KFC. Keep, flip, change. Keep, flip, change. Now you see that this is actually a -2k and a -9, and I have 4 terms. Like terms. Like terms are two terms with the exact same variables. So if I have 3m plus 2m, those two things are alike, and we're going to be, we can combine them together, combine those answers together and get like a 5m. Also, in our last problem, this 5 and this negative 9 are like terms because they do not have a variable that makes them alike. You can add this 5 and this negative 9 together and get a negative 4. Moving on. Coefficients. Coefficient is the number in front of the variable. It's how many of each variable there are. So if I have my expression, I'll make a negative 2y plus 6m. Here I have the coefficient of negative 2 and a coefficient of positive 6. The coefficient is the number in front of the variable. It tells you how many of those things there are. There are 6 m's right here. There are negative 2 y's right here. And the last vocab word we have here is constant. A constant is a number without a variable. So if I had negative 3r plus 19, this 19 is the constant. It does not have a variable. It's just a number. Okay? Now, it is good to know the definitions of these terms because later on, if you look down on the note sheet example 3, it's going to ask you to find these different things from a given variable expression. So knowing that a coefficient is the number in front of the variable, knowing that the constant is the thing without a variable, terms, like terms, knowing those are good things you need to know to be successful in algebra. And definitely distributive property. This guy, not so much. He's not as important. It's good to know what it means, but it's not. It doesn't have an application, a practical use throughout the lesson. So let's go ahead and get through some of these problems. So here we want to apply the distributive property. Now, what that means is we want to take this 4 times by this 3 plus y. Now, the word distribute, the word distribute literally means to give. Okay? So we're going to give this 4 to each piece inside the parentheses. So I'm going to give the 4 to the 3, and by give in this problem we mean multiply. And I'm going to multiply the 4 times the y. And then all we do is simplify what we get. Here we get a 12. Here we get a 4y. And we're done. We used the distributive property. We got rid of those parentheses. Notice our final answer does not have any parentheses. That is going to be one of the most common uses of this distributive property you're going to see throughout the school year. Use the distributive property to get rid of parentheses. It's going to happen a lot. Letter B. Now this time you see the 6 is on the back side after the parentheses. It makes no difference. Remember, if you have numbers like 3 times 4, that answer is 12. If you switch those numbers around and have 4 times 3, guess what? The answer is still 12. It makes no difference the numbers at the end or the beginning. You still take the outside number times all of the pieces inside, all of the terms on the inside. Everything separated by a plus or minus sign. So this gives us 6 times 2. I'll write this one out. This is the last I'm going to write out. 6 times 2 is 12 minus 6 times j is minus 6j. Okay? Now, you do not need to write this step, which I said that's the last problem. I'm going to write this out. It's understood that you have this outside number times inside. And by the way, I've been doing this stuff for years and years and years and years and years and years and years. I still draw my rainbows. That's what I call these guys. I draw my rainbows to show what I multiply together. It's very helpful to make sure you don't make simple little mistakes, especially sign mistakes. Now letter C here looks a little different. Now we have a J on the outside as well. Well, it makes no difference. You can have anything on the inside and outside. You're really allowed to multiply any numbers together. Any letters, any numbers, anything. You can multiply. So here, we just did this stuff in the last lesson, this commutative property. We can take the 3 times the 5 and get a 15j. And we can take a 2 times the 5 and get a 10. And j times j is j squared. Something a little new. I don't know if you've seen before. When you take a variable times by itself, you get squared. Just like if I said 3 times 3 is 3 squared, well, j times j is j squared. Letter D, last one. Draw your rainbows. 5 times negative 3 is negative 15. 5 times negative p is negative 5p. And we're done. So the problems themselves are actually really quite simple. Here's 4 I'd like you to try. E, F, G, H. Pause the video right now. Do them on your own. When you're ready to continue, hit play, and we'll go through them together. Okay, so letter E. So we're going to start by drawing in our rainbows. So you take 8 times y is 8 times y. Because you don't know what y is, you can't actually do that multiplication. And then we take 8 times 6 is a positive 48. And we're done. Letter F. 2p times 3p, and then 2p times 3. So 2 times 3 is 6. P times p is p squared. And 2 times 3 is 6, and p. So when you're multiplying with letters and numbers, multiply the number parts together, multiply the variable parts together, and then just piece those two parts together. Letter G. Draw rainbows this way because the 3 is the number on the outside. He doesn't have anything else with him. So 3 times 2g is a 6g minus, the sign stays the same. Or you should say it's a positive times a negative. You're going to get a negative answer. 3 times 5 is 15m. Letter H. Draw your rainbows. 3 times negative 2 is a negative 6. 3 times negative k is a negative 3k. And that's what we got. Okay? So now let's check out what happens if this outside number is negative. Well, it's the same exact math. The only difference here is now you have to deal with the negatives as you're multiplying. Well, we had some in the last problem too, but look at this. Now we have a negative 8 times g and a negative 8 times 5. Okay, so negative 8 times g is a negative 8g. Negative 8 times 5 is a negative 40. So there's really nothing different about that problem. Letter B. 5, or I guess I should draw my rainbows. This is the number on the outside. So negative 2p times 5. Well, 2 times 5 is 10p. The signs are different. The answer is negative. Negative 2p times by a negative p. Well, negative 2 times negative 1 is a positive 2. P times p is p squared. So remember about if you have a negative in front of a variable, it means there's negative 1 of them. Here's two I'd like you to try, and letter D I have labeled here as a challenge. It's a little bit harder, but give it a shot. Worst thing that happens is we fix it when we go through it together. So go ahead, pause the video, do it now. Okay, so let's see. From here to here and here to here. So negative 2 times negative 3 is a positive 6. The signs are the same, the answer is positive. Negative 2 times r is a negative 2r. The signs are different, the answer is negative. Letter D. Now, let's see. Can I move this challenge over? Good. So I need to draw my rainbows. Negative 3r times positive 2. So negative 3 times positive 2 is a negative 6r. Okay. Negative 3 times negative 3, I'm just doing the number part first. Negative 3 times negative 3 is a positive, not 3, positive 9. And r times p is rp. So we got negative 6r plus 9rp. These variables cannot be combined together because they're different. So we can't say like p squared or r squared because we have two different variables. All right. Not too shabby, not too bad at all. Next is where we have to learn or remember all of those vocabulary words. Because in these problems, this is literally what the problem wants you to do. They want you to just identify what are the terms, what are the like terms, the coefficients, the constants. They want you to identify all of those parts. So let's start, letter A, with our terms. The terms are all the individual little pieces that are being added together. So watch, we have a negative 3y. That is my first term. We have a positive 7j. That is my second term. We have a negative 3y as my third term. And then lastly, a positive 6. I want you to understand why this is a negative 3y. You might look at it and go, that's a minus sign. It's not a negative. Minus signs and negative signs are literally the same thing. It just depends on how you want to use it in each particular problem. This minus sign, I can show you this is negative by doing keep, flip, change. Keep, flip, change. It's still a negative 3y. Okay? You're going to see throughout the course that minus signs and negative signs are the same, and you can decide which one you want to use in each particular situation. If I had a problem, this is off topic, but it's good to understand. If I had a problem, 5 minus 3. Now, I could say that's 5 plus a negative 3, yeah, but it's easier to just go, that's 5 minus 3 is 2. If I had, well, in those last problems, like 3 and then 5 minus y. Well, here, 3 times 5 is 15, and 3 times this negative y, it's easier in this case to think of this as a negative, not a minus, because you can't really do 5 minus y. So the subtraction doesn't work out. But if we think of this as a negative now, we can take 3 times negative y and get a negative 3y. So it's the same symbol that has different uses. It's a minus and a negative. That's very important to make sure you keep track of and remember. Okay, so I wrote out my terms. My like terms. The like terms, if you remember, are all the things that have the exact same variables. In this case, the like terms are negative 3y and a negative 3y. Both of these have the same variable, so they are alike. There are no other j's. There are no other constants, things without variables. So those two do not have like terms. Coefficients. Coefficients are the number in front of every variable. So I have a negative 3 from here. I have a a 7 from this j, and I have a negative 3 from the second y. From here, there's another negative 3. So I have negative 3, positive 7, negative 3. This guy has no variable, so it's not a coefficient. The last word here is constants, and it is the number without a variable. Well, the only thing without a variable is this 6 at the end. That is my constant. Letter B. Terms. So I've got an 8. I've got a negative 3m squared. I've got a negative 5m and a positive 12. The sign in front tells you what that thing is. This is a negative 5m. This is a negative 3m squared. It is a positive 12. Like terms. Nothing here has the exact same variable. I've got m squareds and m's. They might look similar to you, but they're really different things. And you can't say that those two things are alike. But is there anything else there that we could actually add together? The answer is yes. That 8 and that 12. The 8 and the 12 are like terms. I can add and subtract those together. That makes them alike. Okay, coefficients. The number in front of the variables. If there's two terms with variables, you need two coefficients. So here we have a negative 3, and here we have a negative 5. Lastly, constants. Things without a variable, or terms without a variable. We've got the 8, and we've got the 12. That was a big comma. How about that? So we got the 8 and we got the 12. Okay? Recap. Terms. Terms are all the individual little pieces. Make sure you keep the sign with the term. So negatives go with it, positives go with it. Like terms. The things you can add and subtract together. So like 8 and 12. Also, things that have the exact same variable. Like in the first example, the y's. 3y, 3y. Good. Coefficients is the number in front of each variable. If there's a variable, what's the number in front of it? And finally, constants are the numbers without a variable. All right. So nice little recap. There are two problems I'd like you to try. Please do letters C and D right now. Pause the video, do them on your own. When you're ready to continue, hit play, and we'll go through them together. Okay, letter C. Let's see what we got here. Terms. We've got, change color, black. 9b, 6, negative 9, 3b. Those are my four terms. Like terms. What stuff has the same variable? Well, I have a 9b and a 3b. I can add those together or subtract them. But I also have this 6 and this minus 9. Now, hopefully, this is not so good. Here's why. This makes it look like all four of these are alike. We need some way to group these two together and group those two together. Do we have anything in math that helps group things together, keep other things separate? The answer is yeah. We got parentheses. So let's go like this. That says these two are alike and those two are alike. It keeps them separate from each other. Moving on, coefficients. The number in front of the variables. Well, I've got a 9 in front of a b, and I've got a 3 in front of a b. And the things without a variable, there is a positive 6 and a negative 9. So those are my constants. And letter D, terms. 2t, 3w, negative 2s, looks like a 5 is an s, negative 4p. So everything here had a variable. Like terms, which things here have the same variable? The answer is none of them. Nothing here is alike. Coefficients. Number in front of the variable, we got a 2 and a 3 and a negative 2 and a negative 4. Each of the numbers in front of the variables. Make sure you're keeping the signs, the negatives, where you need them. And lastly, constants. Which things here do not have a variable? None of them. Everything here has a variable attached. So there's no terms without a variable. It's none. Okay. So, now we've seen distributive property. We've seen identifying terms, like terms, coefficients, and constants. Let's go ahead and do a couple more problems. These will be from the textbook, from page 97, numbers 1 through 5. Go ahead, pause the video, do these 4 on your own. When you're ready to continue, hit play. We'll go through them together. Okay, number 1. So I'm going to draw my rainbows up here and then put my answer down below. So 2 times x and 2 times 3. So 2 times x is 2x. 2 times 3 is a 6. And they're both positive, so the answer is positive. That one's tricky. Here we have just a negative sign out front. And here we have just a negative y, which is, we know that's a negative 1y. What we haven't seen, at least we haven't seen it many times, is just a negative next to the parentheses. What that means it is a negative 1 times this stuff. So when we distribute, we're going to take negative 1 times a positive 4 is a negative 4 because those signs are different. And then a negative 1 times a negative 1y, which is a positive 1y because the signs are the same. They're both negative. Signs are the same. Answer's positive. Number 3. Let's see. M minus 5. So we're going to distribute this way because this is the number on the outside. So negative 3m times m. And that means there's one of them. So negative 3 is the multiplication of the numbers. M times m is m squared. Negative 3 times negative 5 is a positive 15 because those signs are the same. And bring our m along. Okie dokie, 1/2 times this, 1/2 times that. Now, I don't know if you know the trick to multiplying by 1/2. Multiplying by 1/2 is the same thing as dividing by 2. You're literally cutting the number in half. So 1/2 of 2n, half of 2 is 1n. 1/2 of 6 is 3. And the signs are, everything was positive here, so both my numbers will be positive. Alrighty. Terms, like terms, coefficients, constants. Alright, so identify the terms. We've got negative 7y, an 8, a negative 6y, and a negative 13. So these 3 were all negatives. This guy was positive. Like terms, what has the exact same variable? Well, we've got a negative 7y and a negative 6y. But I could also combine together my 8 and my 13. I can do that math. So that means those are like terms. Coefficients. The number in front of the variable. So we got a negative 7 and a negative 6 because those are my variables and those are numbers in front of them. And lastly, constants, the thing without a variable, I've got an 8 and a negative 13. All right, so we've distributed, we've found our terms, like terms, coefficients, constants. The next and last topic of the lesson is simplifying. You go, ah, great, simplifying, that sounds easy. Well, not as much sometimes. It's not hard. The trick to simplifying is identifying the like terms, knowing which stuff you're actually allowed to add or subtract together, and the rest is easy. So let's see here. Ooh, we've got parentheses. One of the first things you're see we're going to do in a lot of problems this school year is anytime there's parentheses, one of the first steps is almost always get rid of those parentheses by distributing. So watch this. We're going to distribute 3 times m is 3m. 3 times 5 is a positive 15. Write down the rest of the problem. So we distributed. Actually, I guess the arrow's up top there. So we distributed. Now we combine like terms. So what stuff here has the exact same variable? Well, we've got a 3m and a 5m. Those two things are alike. We can do the math with them. We can add and subtract them. Negative 5m plus a 3m. Now think back to your integer rules with addition. The signs are different, so we have to subtract. Keep the sign of the bigger number. So that's what I get if I combine those terms together. Now this 15, he's not being combined with anything, so he just comes along for the ride. So you just bring down a plus 15, and we're done. Negative 2m plus 15. So we distributed to get rid of our parentheses, then looked to see which things have the exact same variable and combined them together. Let's do it again. So now we got more distributing to do, so we can distribute here and distribute there. You're technically allowed to do that all as one step. So let's see here. This gives us a negative 6g. Negative 2 times negative 8 is a positive 16. Positive 3 times 2g is a positive 6g. Positive 3 times negative 1 is a negative 3. All right, now I'm going to use a couple different colors here to help color code everything. So g's, I've got negative 6g's here, positive 6g's there. Those two things are alike. They're like terms because they have the exact same variable. I also have this positive 16 and this negative 3 that are alike. I can combine them together. So let's do that. Since I have my green marker still out, I'm going to do my greens first. So 16 minus 3. You literally do that problem. 16 minus 3. The signs are different. You subtract. You get 13. Negative 6g, positive 6g. Negative 6g and a positive 6g. Those signs are different. So we're going to subtract them. 6 minus 6 is 0. G. And just so you know, we don't write 0g. 0g means there's none of them. If there's none of them, then we don't write it. We're just going to have the answer of 13. Isn't 13 a heck of a lot simpler than this big ugly mess? Because that's what this means. This all means 13. Yeah. So this is a lot simpler. That's the whole point of simplifying, is it takes an ugly problem and makes it smaller and easier to understand. Moving on down, letter C. We're going to start by distributing, so we draw our rainbows in here. This gives us 3 times 5 is a positive 15p. 3p plus 2m, well 3 times 2, both positive, is a positive 6. And this p times the m, well, just gives you pm. And this negative 9p, well, he just kind of comes along for the ride. He's not being distributed. Now, like terms. Well, here we have a p. Here we have a p. This guy is different because he has a p and an m. So he does not have the exact same variables as the other two. So he's not going to be combined. So let's combine 15p and negative 9p. 15 and minus 9 gives you 6p. And then this guy comes along for the ride, 6pm. Okay. Letter D here. Distribute, distribute. That gives me negative 2 times 3 is negative 6g. Negative 2 times negative 6 is a positive 12. Plus 9 minus 2g. So this stuff just came along for the ride. Alright, let's see. We've got a g and a g. We've got constant and constant. So we can combine those pieces together. Let's start with g's. We've got negative 6 here and negative 2 there. We combine those things together. By the way, they have the same sign, negative 6 and negative 2. So we're going to add together and get negative 8g. This 12 and this 9 are both positive, so we're going to add them together, and we're going to get a 21 positive. And that's what we get if we combine them together, if we simplify this expression. So the reason why we're using the distributive property here is to get rid of those parentheses so that we can combine like terms. Combine stuff that has the exact same variable, stuff that we can add and subtract together. Please try letters E through H, E, F, G, H. Go ahead, copy them down, pause the video, do them on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, let's see here. So we're going to distribute here and distribute there. This gives us a 6x plus 3 times 6 is 18. Here we have a negative 2 times 8 is a negative 16. See, it's a negative 2, the sign in front of the number. And a negative 2 times x is a negative 2x. Now, let's see. We've got x's here and here, so let's combine them. Positive 6 minus 2 gives us 4x. Because the signs are different, we subtract. And we've got an 18 and a negative 16. The signs are different, so we're going to subtract. Keep the sign of the bigger number. 4x plus 2. Letter F. Rainbow, rainbow. For distributing, 6 times 5 is 30. 6 times a negative z is negative 6z. And this plus 2z just comes along for the ride. I've got z's I can combine together. Negative 6 and positive 2 gives us a negative 4z. The signs were different. We subtracted, kept the sign of the bigger number. And this 30, nothing's happening with him, so he just comes along. 30 minus 4z. Number letter G. Distribute, distribute. 3m plus 15 minus 10. I do not have any other m's, so nothing's happening with him. 15 and 10, though, I can do that math. 15 minus 10 is 5, and this 3m comes along for the ride. So 3m plus 5. This is being multiplied by those parentheses, so we've got this gives us a 12r, and 3 times negative 6 is negative 18. And don't forget about this 12r out front. Like terms, 12r and 12r, they have the same variable, so you combine them together. 12 plus 12 is 24r, and this minus 18 doesn't have anything that's combining with it, so he just comes along for the ride. And we're done. Okay, so we've got, looks like 2 problems out of the textbook. I lied. 1 problem out of the textbook, and then we will call it a day. So please do number 9, or from page 98, number 6 right now, and we're done. Okay, hopefully you did it. If not, pause the video and keep working. Let's see, distribute, 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 distribute. This gives us a positive 30. That gives us a positive 5n. Negative 2 times n is a negative 2n. Negative 2 times by negative 2 is a negative 4. No, I lied. Positive 4. Negative times negative is positive. Signs are the same. Answer is positive. All right. Combining like terms, we've got some n's, positive 5 and negative 2n. I can combine together. Those signs are different, so I'm going to subtract them and get a 3n. And then this 30 and this 4 are also alike. I can combine them together. They're both positive, so when you add it up, you get 34. So 3n plus 34, and we're done. Go ahead and answer the summary. It asks you, how do you use the distributive property to simplify expressions? What did we do in those problems? Why did we use this distributive property? How did it help us? Go ahead, write a sentence. We'll get back together here in just a second. So the answer I came up with was, you use the distributive property to get rid of the parentheses. You should have said that, because that was the whole point of the distributive property in those problems, was to get rid of those parentheses. And then after the parentheses were gone, it says, then you can combine like terms. So that was the whole point of those, of the distributive property. Okay, here, so we've got a couple homework problems from page 99, numbers 1 through 12, and 25 through 32. This has been lesson 2.5. Thank you for watching.